So now we're going to look at the parabola and the geometric definition of a parabola, and then use that to derive the formula for a parabola based on that geometric definition. So for the geometric definition, what you have is a parabola is all the points that are equidistant from a single point, and that point is called the focus, and a line called the directrix. And all these points, when you do this calculation, end up to be the same distance away from these two things. So if we take a look at it, what that means is you're going to end up with a point. So in this case, what we're going to do is we're going to say that the point is 2 over and 3 up. And so there's our point. That point is going to be called the focus. And then our directrix for this problem is going to be y equals 1. This horizontal line, y equals 1. So if you think about the one easy point to find that is equidistant from these two, it is a point directly in the middle of them. And if you notice, it's going to have the same x-coordinate as the focus, and then it's going to have a y-coordinate in between those two y values. And so it turns out to be 2, 2. This one was 2, 3. And then, and so that has a name in and of itself, that easy point to find, the point that's just right in between those two, the shortest distance, if you will, between them, and that is the vertex. And then all the other points we're going to just refer to as x, y. So to find the equation here, what we're going to do is, looking at this information, is we're going to use the distance formula. We're going to say that the distance from the focus, 2, 3, to xy can be calculated this way: x minus 2 squared plus y minus 3 squared. And then that's going to be equal to the distance from this coordinate down to this horizontal line, y equals 1. Well, that distance just turns out to be y minus 1. So now we go through and we square both sides. And so we're going to go through and square both sides. The left side square just gives us the same thing without the square root. I'm not going to multiply out the x minus 2 squared because I know what's coming. I'm going to leave it as it is. But I am going to multiply out the y minus 3 squared. And then I need to square both sides, so I need to square y minus 1, which gives me y squared minus 2y plus 1. Now, the way that I'm going to do this is I want to collect all the y's on the one side. The first thing that we notice is that we have this nice thing that happens with the y squareds canceling out. If I add 6y to both sides, I end up with 4y on this side, and then if I subtract 1 from both sides, I end up with 8 over here. So just doing some simple manipulating, we end up with x minus 2 squared plus 8 equals 4y. Well, to put it in function form, we want it as a y equals. And so we're going to divide through by 4. And what that ends up giving us is this equation: 1/4 times x minus 2 squared plus 2 equals y. Alternatively, it also equals this, which is an important thing. I'll show you why in a second. Okay. First thing is, you notice, especially if you look in this form, the vertex was 2, 2. And you see the 2, 2 showing up in these two right here, where the vertex is just going to be equal to the whatever those values are that attach to the x, and whatever the value is that's attached to the y. And then this isn't as obvious what it is, and it turns out that we have what we refer to as a c value, and the c value is this length right here. And since that's 1, the way that we actually learn about it is it turns out to be 1 over 4c. So the general form is this. Y minus 2 equals 1 over 4c. So the 4c is on the denominator. Not y minus 2, y minus k. And then x minus h squared. And you can see that all those showed up in the way I just did that. All right, so now let's do it in a general form. If you're interested in that, I'd stick around and watch this part in a general form. If we do it in a general form, it's basically the same idea, except that we're going to start with the vertex, and we're going to call that vertex h comma k. And then we're going to find the focus by adding c to the k and subtracting c. And then we're going to find the directrix, this line, by subtracting c from the k. So it's going to be y equals k minus c. And then we're going to have some point on here, and so that's going to be this line like this. Some point that is going to be xy. And so when we do our distance formula, we find the distance from the focus, h comma k plus c, to x comma y. So again, it's going to be done the same way we just did it, which is x minus h squared plus y minus k plus c squared. And then that's going to equal the distance from the point down to this directrix line. Well, this distance is just going to be y minus whatever the y coordinate is of this point, which is just the value that y is equal to for that horizontal line, so k minus c. So the distance here is going to equal y minus k minus c. Square both sides. Similarly, like I did before, I'm not going to multiply out the x part because we're going to want to leave it as it is. We need to multiply out this y part, so it's going to be y squared minus 2y times k plus c plus k plus c squared, which turns out to be k squared plus 2kc plus c squared. And that's going to equal y squared minus 2y times k minus c plus k minus c squared, which would give you k squared minus 2kc plus c squared. Where the really good thing that happens here is all kinds of stuff cancels out. Y squared cancels out. The 2yk cancels out. Now, notice on the 2yc, this is negative 2yc. This is going to be positive 2yc. So on our right side, we're going to have a positive 4yc on that right side, because we got negative 2yc on the left, positive 2yc on the right. K squared cancels, c squared cancels. Same thing happens with this. We're going to subtract because those signs are different. So that's going to give me minus 4kc. Now I'm almost done. I divide through by my 4c. You start to see where that 1 over 4c comes from. So that gives me 1 over 4c times x minus h squared equals, well, y minus k. And so that's where all of that comes from and why this works out. Things change if you end up with an upside down parabola. It all works out to be the same. The derivation looks the same. You just have to be careful with your negatives. And also, if you do it side to side, we'll learn how this all applies to that as well. We'll do another video that goes some examples and shows you how to use this information to find out more things about the parabola.